Hello everyone, so welcome to my YouTube channel. So guys, in today's video we are going to continue with the thermodynamics. So in the last class we have seen, like, we were studying about the measurement of delta U and delta H by the calorimetry. Okay, so last class we have seen how we will do a delta U measurement by using a bomb calorimeter. Okay, and this process is important. Even in your board examination they can ask. Okay, you can say the maximum chances that they can ask this measurement of delta U. So remember, we have to remember the process. If they will say the measurement of delta U, so it is by bomb calorimeter. Okay, delta U measurement, that method is called as this bomb calorimeter. Okay, and next in today's class we are going to continue with a measurement of delta H, or we can say delta H measurement. So delta H measurement is coffee cup calorimeter. Okay, the name of this is coffee cup calorimeter. So measurement of delta H is by using bomb calorimeter, and measurement of delta U. Okay, measurement of delta U means measurement of change in internal energy. Delta U means nothing but change in internal energy. And understand one more thing, I sometime in place of delta U they will say delta E. So both is nothing but change in internal energy. Okay, so measurement of delta U or measurement of delta E or measurement of change in internal energy is done by a bomb calorimeter. Okay, then measurement of delta H or measurement of change in enthalpy, that is done by coffee cup calorimeter. The name is very important. Okay, so measurement of delta H is with coffee cup calorimeter. So guys, this is very easy and very important. Also in the last class we have seen about the how the working of bomb calorimeter will happen, and what is the every part functions in the bomb calorimeter. We see the bomb, we see the sample. Okay, we see the water, then insulator, then stirrer, then thermometer. So we saw that the function of every parts in the bomb calorimeter and how the whole bomb calorimeter works. So now here also we are going to see the functions of each and every part of coffee cup calorimeter, and then we will see the working of coffee cup calorimeter. Okay, so coffee cup calorimeter means it's look like this. So here first of all we have this outside cup. Okay, that's called polystyrene cup. Inside that again we have another cup. Okay, this one, in which we will put the reaction mixture. So what is that, guys? Outside we have one cup, that is called polystyrene cup. Inside that again we have a small cup. So in that cup we have to put the reaction mixture. Okay, so it's like this. Outside we have one foamed polystyrene cup. After that inside we have another cup. Inside we have another cup. In this cup we will put the reaction mixture. Okay, so let's see. Okay, wait. See here, measurement of delta H is with coffee cup calorimeter. So what is this? A coffee cup calorimeter is a simple, inexpensive device. So coffee cup calorimeter is what? Is a simple and inexpensive device. Okay, by seeing only we can get to know it's like, see, the simple and it is inexpensive device. What is used? Used to measure the heat of reaction or physical process, particularly those occurring at constant pressure and in aqueous solution. So mostly, see, delta H, whenever we'll talk about H means enthalpy. So whenever we talk about enthalpy, we will say heat content. Okay, how much heat content? Okay, heat content means heat absorbed, or during the reaction how much the reaction contain the heat. So that's why what we say that a coffee cup calorimeter is a simple inexpensive device. Like Bob calorimeter is also a device. So coffee cup calorimeter is a simple inexpensive device. What is used? Used to measure the heat of reaction. Used to measure the heat of reaction. Why? Because we are doing? We are doing the measurement of delta H. So delta H means what? Enthalpy. Enthalpy means heat content. So that's why they said a coffee cup calorimeter is a simple inexpensive device used to measure the heat of reaction. So whatever we are doing the reaction, it's heat of reaction. And how we will measure? We will measure by this thermometer. Okay, so delta H means heat content. So that's why a coffee cup calorimeter is a simple inexpensive device used to measure the heat of reaction. Heat of reaction how? Particularly those occurring at constant pressure. Very important thing, guys. We are not going to change the pressure, because what will happen if we'll change the pressure? The volume will change, right? If suppose if you will increase the pressure on the system, so what is happening? Pressure is increasing, so volume is decreasing. If you will, what you will do? If you will do the expansion, so what is happening? Pressure is decreasing, so volume is increasing. Okay, so that's why we don't want the change in pressure. What we want, remember this, guys. This is very, very important. Whatever we are going to do, we will do at constant pressure. We are not going to change the pressure. So that's why measurement of delta U or measurement of delta E or measurement of change in internal energy is by Bohm calorimeter. Now measurement of delta H or measurement of change in enthalpy is by coffee cup calorimeter. So coffee cup calorimeter is what? It is simple inexpensive device. And what is being used for? Used to measure the delta H means what? Heat. So heat of what? Heat of reaction. So heat of reaction or physical process, or heat of reaction or physical process, particularly important, okay, particularly those occurring at constant pressure and aqueous solution. Main important thing is constant pressure and in aqueous solution. Okay, so pressure should be constant in coffee cup calorimeter. Now we will see one by one part. First is styrofoam cup. This is this foamed polystyrene cup is this styrofoam cup. Okay, so this is the styrofoam cup. So the main body of the calorimeter, see this one, this is what, this is this okay, this is what, this whole the main body. What is this? Is a foamed polystyrene cup and this styrofoam cup. So the main body of the calorimeter is usually a styrofoam cup. This material is a good thermal insulator. What do you mean by the word insulator? Very good. Jaldi bolo bhaiya. What is the meaning of insulator? Insulator means which will not allow the heat to pass. So thermal insulator, name itself indicates thermal means heat. Insulator means it will not allow to pass. So thermal insulator, it will not allow the heat to pass from system to surrounding. Okay, it will not allow the heat to pass from system to surrounding. So styrofoam cup, or we can say foamed polystyrene cup. This is this outside. Okay, so see, we are dealing where? We are dealing here. Okay, so this is what? This is our system. And outside is what? Outside is the surrounding. So this foamed polystyrene cup, or we can call it as styrofoam cup, it works like a boundary. Between the system and the surroundings. So which type of boundary we have? We have thermal insulator, means heat insulator. Thermal insulator means heat insulator, which will not allow the heat to pass from reaction sorry, system to surrounding or from surrounding to system. It will not allow. So that's why we will take at first thing is important at constant pressure. Okay, so styrofoam cup means the main body of the calorimeter is usually a styrofoam cup. This material is a good thermal insulator. What it will do? It will do minimizing heat exchange with the surroundings. It will minimize the heat exchange with the surrounding. So system to surrounding no heat, surrounding to system no heat, because it is thermal insulator, heat insulator. Okay, next thing is, this is what, this is a construction. This is the basically construction means, first of all we will explain about this, what is coffee cup calorimeter, then we will explain each and every part of the coffee cup calorimeter, then we will write down its working. Okay, so first this is called as a construction part. Construction part means we will explain about each and every part of the coffee cup calorimeter, then we will write the working. Now next is inner cup. Inner cup means this, what I said na, there are two types of cup, sorry, there are two cup. First is this outside foamed polystyrene cup or styrofoam cup, which is insulator, which is thermal insulator. Inside this we have one more. See, I had made na, blue color is outside, red color is inside cup. So inside you can see here, see this one, this inside cup. Okay, so that's why the inner cup. Inner cup means a smaller cup. A smaller cup is placed inside the styrofoam cup to contain the reactants. So the inner cup, in that we will put the reactants. Well, this reaction mixture here you can see. This is a one more cup inside. One more cup we have inside. In this we will put the reaction mixture. Reaction mixture is nothing but reactants. Okay. So now what will happen? Thermometer. What is the work of thermometer? We all know. A thermometer or temperature probe is used to measure the temperature change of the solution. So this is the solution. Whatever the temperature change will happen, the thermometer will measure. Now steering mechanism. So what will happen is steering mechanism, the work we know already. We have seen in the bomb calorimeter also, when the heat will come outside from the what will happen inside the bomb, we will take the sample, we will burn the sample in the presence of excess oxygen, right? The oxygen inlet will supply the oxygen. So what will happen when burning will happen inside the bomb? So now the bomb will release the heat, so heat will go to the water because bomb is kept inside the water. So what will happen? Heat is releasing to the water, so that's why we use the steering mechanism. So that's why heat will not get trapped at one place in the water. If you will use the steering mechanism, so what will happen? It will stir the water, so that's why heat will get uniformly distributed in the water. So that's why we can easily dip the thermometer anywhere in the water and we can measure the temperature. So that is the use of steering mechanism. So what a steering mechanism will do, whatever the heat is producing, steering mechanism will mix the heat. Okay, uniformly it will distribute the heat into the water. So that's why heat will not get trapped at one point of water. So heat will get uniformly distributed in the water. So that's why anywhere in the water we will dip the thermometer and we will find the temperature. So that is the work of steering mechanism. It ensures uniform temperature distribution in the water to get accurate temperature readings. Okay, otherwise what will happen? If we will not use the steering mechanism, so the heat is coming. So nearby water it will be more heat because the heat will get trapped in near the water. After the water which is away from the heat, it is showing the different temperature. So when we will dip the thermometer at different point, we will get the different reading. So we will not get the accurate temperature reading. We will get the different temperature readings. So that's why we will use the steering mechanism. So when the steering mechanism will be there, it will stir, and what it will do? It will means whatever the heat is producing, it will uniformly distribute the heat into the water. So that's why heat will get uniformly distributed in the water. So what will happen? Whenever we'll dip the thermometer anywhere, we will get the same, means you can say accurate temperature reading everywhere, same temperature reading everywhere. So why this is? Because the reason is heat is uniformly distributed in the water. So that's why steering mechanism being used. Now next is lid. It's optional. Lid we know, right? It is used for closing lid. So lid is optional. A lid can be placed on the top of the cup to reduce heat loss to the environment, although it is not always necessary. So lid is like optional. It will not use. We will not use it. Like it is not necessary. Okay. So this is about the coffee cup calorimeter. So this we have seen the coffee cup calorimeter, and then we have seen the construction of the coffee cup calorimeter. Now what we will do, we will see the working. So how the working will happen here? See, the reactants means in the reactant means what? We will say it as system, because we will focus on there, right? We know the system is what, on which we will observe, that is system. Other than that, surrounding. So reactants, where the reactant means what? Reactant will go under the process of reaction. The reactant will go under the process of reaction. So we will focus there only, where the reaction is happening. So that's why the reactant is also called as system. So the reactant system are placed in the inner cup, and the reaction that place, and the reaction and the reaction takes place in the solution. So what will happen? Okay guys, see how you have to write is, first of all you start from here. Okay, this thing you have to write. Then after that you have to write the styrofoam cup, inner cup, thermometer, steering mechanism, lid, optional, then this working. Okay, till here. Okay, I will tell you, see how I am explaining, like that only you have to write. Don't start writing randomly anything. Okay, so working, we get to know the reactant means the system are placed where we will place, placed in the inner cup, because we have a two cup. One is the outside, the thermal insulator cup, styrofoam cup. Another one is inner cup. Okay, so that's why the reactant system are placed in inner cup, and the reaction takes place in the solution. Okay, we will keep in the inner cup, and the reaction takes place in the solution. So what will happen then? As the reaction takes place in the solution, the heat produced, okay, either it will produce the heat or absorbed. So heat produced or absorbed by the reaction change the temperature of the water. Water means surrounding in the cup. Okay, so what will happen when the reaction is going on here? Okay, when the reaction is going on here, so what will happen? The two things will happen, either exothermic or endothermic. If endothermic will happen, then it will absorb the heat. If exothermic will happen, it will release the heat. Okay, so the heat produced or absorbed by the reaction, so what it will do, it will change the temperature of the water. Water means surrounding. It will change the temperature of the surrounding. So what will happen? The temperature change of water is recorded. Okay, the temperature change of the water, why? Because the heat is being released and it will go into the water. Then with the stirring mechanism will stir the whole water, so that's why heat will get uniformly distributed in water. And then we will with the help of thermometer, we'll check the temperature of water. So the temperature change of water is recorded before and then after the reaction. The heat absorbed or release is calculated by, after this guys, till here. Now we have to write here. So what will happen? Either heat will absorbed by the reaction or heat will released by the reaction. Okay, so whatever will happen, there is a change in the temperature of the water. So we will calculate the temperature, means by the thermometer we will see, we will dip the thermometer at the starting, we will measure the temperature, then we will dip the thermometer after the reaction. So when either heat will released or heat will absorb, so there is a change in the temperature of the water. So that's why we will record, and we will get to know how much it changes. Okay, so that's why next you have to write this, the heat absorbed or released is calculated by, after that you have to write down this. So guys, we know we have taken at constant temperature. Whatever we are taking at constant, pressure, constant pressure. Okay, we have already seen that we will take the constant pressure. What we will do, we will take the constant pressure. So constant pressure, what will happen guys? We have seen the two condition. We have seen just now, we have seen the two condition. First condition is what? Heat released. Second is heat absorbed. Two things will happen, either heat released exothermic or either heat absorbed endothermic. So what will happen? First is heat released. We will write heat is released. Heat is released. From where heat is released? Joldi 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 bolo bhaiya, aur ye bhaiya joldi joldi. Heat is released. From where the heat is released? Main thing is yes, yes. If you are giving the answer yes, heat is released means, guys, what is happening? Everything is happening in the reaction, right? Reactant is reacting, so reaction is happening. So where we will focus? We will focus on the reaction. Where we will focus? We will focus on the reaction. So that's why reaction is our system. So if heat is released, so heat is released from where? Heat is released from system to surroundings. Heat will released from system to surrounding. So what will happen? First condition is heat is released from system to surrounding. So what will happen? Heat we will find QP. Why? Because at constant pressure. Heat at constant means heat is released from system to surrounding at constant pressure. So QP. Okay, yes sir. So guys, heat is releasing means exothermic. So exothermic means negative Cp delta T. Okay, Cp means constant pressure and delta T means heat is releasing. So obviously either heat will release or heat will absorb. There is a change in temperature. So delta T. Okay, yes sir. So Qp is what? Wangran. Qp is, we know, delta H. Qp is what? Joldi joldi bolo bhaiya. Delta H, right? QV is delta U. QP is delta H. Delta H is equal. Now if I will write in the terms of mass, mass will come. So what will happen? C M. C means specific heat into M. M means mass and then delta T. Mass of what? Mass of what? Mass of joldi joldi re bhaiya. Mass of water. Why? Because the water is present there. Okay, mass of H2O, water. Okay. So we know, guys, understand one thing, a specific heat. C is the specific heat of what? Joldi joldi. Specific heat of water. Main thing is, guys, either heat will release or heat will absorb. There is a change in temperature in the water. There is change in temperature in the water. There is a change in temperature in the water. So that's why a specific heat capacity of what? Water. You remember the thing, it is 4.186. remember this value, 4.186, 4.186, 4.186, 4.186. Okay, now next we will see first is done, heat is released from system to surrounding. This is the formula, minus Cp delta T. If we will take the mass of the water, it will become minus Cm delta T. Yes sir, yes sir, yes sir. 3 back full. Now next is what? Next is heat is absorbed. Next, what is the condition it can be? Next condition is heat is absorbed. Heat is absorbed from where? Heat is absorbed from surrounding to system, because heat is absorbed. Who will absorb the heat? System will absorb the heat. So heat is absorbed from system to, from surrounding to system. Heat is absorbed from surrounding to system. So what will happen? See, heat absorbed from surrounding to system, I will take as a Q, because heat is denoted by Q at constant pressure. The QP, heat is absorbed. Heat is absorbed means plus sign, at constant pressure means Cp, constant pressure, and obviously either heat is absorbed or heat is released. There is a change in temperature, so delta T. Okay, yes sir. Then Qp is equal to, sir, delta H, we know this, sir. Then the same thing will happen, guys. In place of minus, it will be plus C into M into delta T. C is what? C is the specific heat capacity of water. M is the mass of the water. Okay, yes sir. Specific heat capacity of water is this, sir. Yes sir. Done, sir. Okay, fine, very good. After that, we will come for the next is standard state of element. Very important guys, definition is very important in examination. In the main examination they will ask the definition. Chalo bhaiya joldi joldi re, अरे joldi joldi re. First is what? Standard state of element. Standard state of element. Now see, standard state means by the name we will get to know the element which is present in its standard state, the element which is present in its standard state. So we have to focus on few elements and you have to remember that which element is present in, means it's what their standard state. So we have to remember, because in the examination they are going to ask. If you know it, you know it. If you don't know, you don't know. You will lose the marks. Ashte. So standard state of element, see here, the standard state of an element refers to its most stable physical form. Because standard, when you are in the standard form, when you are at the most stable physical form, when you are at the most stable physical form, then we will say that it is in standard state. Then we will say it is in the standard state. The standard state of element, when joldi joldi, yes, when you are at the most stable physical form. The standard state of an element refers to its most stable physical form under standard condition. Under standard condition. Standard state means at standard condition. If you are talking anything about the standard, we want it in a standard only. Okay, because in life you will say a standard wala. Yeah, I want my pookie partner standard, so we have to maintain the standard. Everything should be in the standard condition. Okay, standard condition. So standard state of element means the standard state of an element refers to its most stable. Because if you are not stable in your life, how you will find the standard, right? My God, so standard state of element means the standard state of an element refers to its most stable physical form under standard condition. So what is the standard condition? Joldi joldi bolo re bhaiya. Standard condition is 1 atmosphere of pressure, means 1 atm atmospheric pressure, and a temperature of 25 degrees Celsius. That is called as room temperature. Now don't start fighting, sir. Room temperature is 27 degrees Celsius. How you will say 25? Nahi bhaiya. Room temperature is 25 degrees Celsius, and the standard we will write temperature in Kelvin. So it will be 298 Kelvin. The standard state of enthalpy is what? The standard state, of an element, enthalpy. Sorry guys. The standard state of an element refers to its most stable physical form under standard conditions. Definition important hai bhaiya. So what is the most stable physical form under standard condition? What is the standard condition? 1 atm and a temperature of 25 degrees Celsius, which is room temperature, nothing but 298 Kelvin. Okay. See, it is a state in which the element is most commonly found at room temperature and pressure. Room temperature and pressure. Okay. Yes, sir. So these are the standards. So element, carbon, if we'll talk about the carbon, so carbon is standard in its graphite form. Carbon is having, diamond, graphite, Buckminster Fullerene. So element, carbon, standard state of carbon is graphite form. That is carbon. This is what? This I will say you, solid. Okay. After writing this, okay, then you have to start from here. So as I've said you guys, how I am explaining, you have to write like that only. Okay. Standard state of element, this thing here. So if you take the element oxygen, its standard state is O2. Don't write the oxygen O. We are talking about element. So it will become O2. O2 element, gas. Then nitrogen, N2, standard state in gas. If they will write N2 in solid, it is not in the standard state. N2 in gaseous form, then only it will be in a standard state. Bromine, Br2 in in liquid form. Okay, in liquid form. Element iodine, which is I2 in solid form. Iron, Fe in solid form. Sulfur, S8 in solid form. chlorine, Cl2 in gas form. These are the elements whose standard state you have to know, so that's why it will be easy for us to solve the problems, otherwise it will become problem. Okay, fine. Okay, so now after this in a note we will write, अरे not I बहुत cheating hai guys, cheating. I have a lots of space. They will say it's not a lots of space. Okay, stop it, stop it, stop it. Okay, so after this we get to know how to write, right? We'll start from here, measurement of delta H. We'll write all these things, then we will write the working. After working we'll come to the standard state of enthalpy. No, sorry, after working, yes, here the heat absorbed or released is calculated by, till here you will write, then you have to write down this whole slide. Then after that you have to start with this one, standard state of enthalpy, sorry, standard state of element. So you have to write this whole standard state of element till this, okay, box. Then after that don't write anything. Then after that you have to write down this in the note, give the arrow and write down this white phosphorus. This is very important guys, they have asked in the examination in MCQ. White phosphorus is not the most stable. White phosphorus is not the most stable form of phosphorus. Okay, white phosphorus is not the most stable form of phosphorus at standard conditions. This is the assumption. What we know guys, if we will take the standard condition, what will happen? That element will become most stable. If most stable means it is in the standard form, right? But they said that white phosphorus is not the most stable form of phosphorus at standard condition. The reason behind is because it is the most commonly found and used form in practical situations. This is the reason, because we know that if we will take the any element in the standard conditions, it will be most stable, then it will be come under standard state of an element, right? But the white phosphorus is not. If you will keep the white phosphorus at standard condition, it is not the most stable form of phosphorus, because it is the most commonly found and most commonly used form in practical practical situations. Okay, yes sir. Then next, after this we will continue here. The definition, standard enthalpy of melting. Guys, melting means what? Melting means we are going from solid to liquid. That is also called as standard enthalpy of fusion. Both are same, don't get confused. Okay, standard enthalpy of melting or standard enthalpy of fusion. So melting or fusion means solid to liquid, when we'll go from solid to liquid. Okay, so standard enthalpy means, understand one thing, enthalpy means this, delta H, standard means this I will use, delta H naught. So H naught indicates the standard. Okay, standard enthalpy of melting or standard enthalpy of fusion. So this process is from solid to liquid, when we'll go from solid to liquid. So what will happen? This is the amount. Okay, this is the amount. Okay, now we have to write this standard enthalpy of melting. So the amount of heat, see, standard enthalpy of melting. So what? Enthalpy means what? Heat required for melting. Enthalpy of melting means heat required for melting. Enthalpy of vaporization means heat required for vaporization. Okay, So standard enthalpy of melting means the amount of heat required to melt. Melting means melt. The amount of heat required to melt 1 mole of solid at its melting point. So melting means solid will melt to liquid. Vaporization means liquid will vaporize to gas. Okay. So that's why standard enthalpy of melting means the amount of heat, because enthalpy means heat content. The amount of heat required to melting means melt. How much? Standard means we will take a 1 mole of what we will melt? Solid. So that's why the amount of heat required to melt, because melting process means melt 1 mole. Standard means what will take? 1 mole. 1 mole of what? What will melt? Solid at its melting point, because solid will melt at its melting point, and 1 atm at constant pressure. We know guys, pressure means what we will say? We know that at constant pressure, whatever we are going to do, we will do at constant pressure, because what we will do, whatever we will do at standard conditions. What we will do at standard conditions. So that's why it is standard enthalpy of melting, standard conditions, then only it will become standard enthalpy. So what is the standard in condition? Remember the thing, standard condition is at 1 atm, not that atm, okay, atmospheric pressure at 1 atm and at constant pressure, at 1 atm and at constant pressure. Okay. So standard enthalpy of melting means the amount of heat, because of enthalpy I will say amount of heat required to melting means to melt. How much? Standard means 1 mole of solid, because solid will melt 1 mole of solid at its melting point, and 1 atm constant pressure. Okay. So example, melting point of ice, because solid is ice, melting point of ice is 0 degrees Celsius, pressure is 1 atm. Delta H fusion means this. Okay, enthalpy of fusion or enthalpy of melting is plus 6 points. See, this is for ice. Okay, enthalpy of melting or enthalpy of fusion of ice is plus 6.01 kilojoule per mole. Plus means heat is given for melting. If heat is given for the melting means plus, or heat is taken out means minus. Okay. Next we will write this standard enthalpy of vaporization. Vaporization means liquid to gas. Vaporization means liquid to gas. So the enthalpy means what? Amount of heat required. Amount of heat required to vaporization means how we'll do the vaporization? Boiling. So amount of heat required to boil, because here melting, how we'll do the melting? Amount of heat required to melt. So here amount of heat required to boil. And standard means what we will take? 1 mole of what we will boil? Liquid. 1 mole of liquid at its boiling point, and 1 atm again at constant pressure. At constant pressure. Constant pressure. Okay. See the same enthalpy. So that's the amount of heat required. If it is melting, to melt. If it is vaporization, to boil. Okay. What? Standard means what? 1 mole. If melting means 1 mole of solid at melting point. Boiling means 1 mole of liquid at boiling point. And then standard condition. Standard condition is 1 atm and constant pressure. That's it. So we have to boil the water. So boiling point of water is 100 degrees Celsius. Pressure is 1 atm. Then delta H vaporization is for water. Water is plus 40.79 kilojoule. Plus means heat is given for boiling. If heat is taken out means minus. Okay. Now next is standard enthalpy of sublimation. Sublimation means from solid to gas. So enthalpy means same. The amount of heat required. The amount of heat required. So sublimation means what? To sublime. Right? Amount of heat required to sublime what? Standard means what? 1 mole of what will sublime? Solid at its sublimation point. Melting means at its melting point. Boiling means at its boiling point. Sublimation means at its sublimation point, and 1 atm again at constant pressure. Okay. So this, I hope you understand this 3. Then next is the same example means sublimation point of dry ice. The best example, solid to gas. Dry ice. it is 198 Kelvin. Pressure at 1 atm, then delta H for sublimation is this, plus 25.2 kilojoule per mole. Again plus means heat is given, minus means heat is taken out. Okay, so see, this all are related, linked to each other. Enthalpy means what? Enthalpy ke chalte, because of enthalpy we are using amount of heat required. Okay, and then we will see melting means amount of heat required to melt, vaporization means to boil, sublimation to sublime, right? And what standard form? Standard form means 1 mole, right? For melting, 1 mole of solid will melt at melting point. Vaporization means 1 mole of liquid, right? Liquid will vaporize to gas. 1 mole of liquid at its boiling point. Sublimation means same, what we will take, 1 mole of solid will sublime, right? 1 mole of solid at its sublimation point. And standard condition, what is the standard condition? Joldi joldi bolo, joldi joldi. Yes, standard condition is 1 atm and constant pressure. Okay, next we will see is enthalpy of formation. Next is what? Next we will see is enthalpy of formation. Enthalpy of formation. So enthalpy of formation is this, right? H means enthalpy. So guys, this is not enthalpy, same is standard, because here we are talking about standard. The standard enthalpy of formation. Delta H is enthalpy of, okay, and standard means this, and formation. Okay, enthalpy of formation, and this is standard enthalpy of formation. Here we are talking about standard. Why? Because we will take the standard state of element at standard condition. What is standard condition? 1 atm at constant pressure. Okay, so enthalpy of formation. Formation means what, guys? We will form, right? Formation means what? We will form. And what we will form? We will form the product, right? We will form the product. From where we will form the product? From the reactant. The reactant will react with each other and we will form the product. So enthalpy of formation means what? Formation of product. So standard enthalpy of formation means heat exchange that takes place at constant pressure. Obviously at constant pressure. Why? Because it is at at standard condition. Standard condition means constant pressure. So enthalpy of formation, right? We are forming the product. Okay. So enthalpy means what? Again, heat exchange will happen. So heat exchange that takes place at constant pressure while formation of, right? Formation. So while formation of what? What we will form? Standard. We will form the standard. So standard means what? 1 mole. Guys, don't forget to write the 1 mole if we are using the standard. Otherwise, if you forget that to write the mole, it will become moi. Okay, so standard enthalpy of formation means heat exchange that takes place at constant pressure while what? Formation means while formation of what? 1 mole of a compound from the element. 1 mole of compound from the element in their standard state is called enthalpy of formation. We will form the compound from the element and everything will be under standard state. Standard state means 1 atm at constant pressure. Okay, unit is kilojoule per mole. Now this point is very important. This point is very important. Enthalpy of formation. Okay, enthalpy of formation of any standard state. If suppose we have taken an element in its standard state, okay, standard state of an element, we have taken the element, okay, in its standard state. So any element which is present in its standard state, if we have to find the enthalpy of formation of that element which is present in standard state, every time it is 0. Every time it is 0. So enthalpy of formation, if you will do the enthalpy of formation of any standard state of an element, the element which is present in the standard state is 0. Okay, remember this thing, very important. Now enthalpy of reaction. Enthalpy of, again this is standard. Okay, standard enthalpy of reaction, because this node indicates standard. In standard enthalpy of reaction, reaction means, guys, obviously reaction means what? Reactant side reaction is happening during a chemical reaction. Okay, so again enthalpy means total heat exchange. Total heat exchange means either it will release or either it will take. So total heat exchange, see, exchange means between system and surrounding, so either it will release or either it will absorb. So total heat exchange taking place at constant pressure, everything will happen at constant pressure. The total heat exchange taking place at constant pressure during a chemical reaction, because it is enthalpy of reaction. So during a chemical reaction, its unit is kilojoule. Okay, so this is the formula, guys. For finding the enthalpy of reaction, we have to do this standard enthalpy, summation of standard enthalpy of product minus summation of standard enthalpy of reactant. Okay, so what we have to do, we have to for finding the enthalpy of reaction, what we will do, summation of enthalpy of product minus summation of enthalpy of reactant. Okay, summation of enthalpy of this formation of product minus enthalpy of the summation of enthalpy of formation of reactant, means product minus reactant. Okay, now we will do the sums, then we will understand, and then last we will do the enthalpy of combustion. Okay, ठीक है. Till here you have to write as it is, how I had explained. Okay, just now how I explained, you have to write as it is. Okay, then now after this enthalpy of reaction, we'll solve the problem. Chalo bhaiya. See, the question number 1 is combustion peak problem, है ना, combustion peak. Okay guys, I will tell you one thing for this thing. First I will tell you this thing is, which is very important, this thing. Enthalpy of reaction means what we will take, summation of enthalpy of formation of product minus summation of enthalpy of formation of reactant. Okay, so let's suppose how it happens. Let's suppose if I will take A plus B gives C plus D. So this means, see, capital A, capital B, capital C, capital D means capital A, capital B indicates the reactants. We have some reactants, we don't know, whatever, we have some reactants, and C and D we will get the products. Okay, A and B are the two reactants which react and they will give the product C and D. So small a, small b, small c, small d indicates any stoichiometric coefficient, it indicates any coefficient. What it indicates? It indicates any coefficient. Okay, maybe it will be 2, 1, 3, any coefficient. Okay, so see how we will get this enthalpy of reaction. So what we have to do in enthalpy of reaction, first of all we have to do the enthalpy of formation of product minus enthalpy of formation of reactant. So see, enthalpy of formation of each and every product and then enthalpy of formation for each and every reactant, they will give in the question itself. We should not have to find, or we should not have to remember anything. Okay, the values, like you can see here, the values, if you will see here, see this. Okay, this, what is this? Enthalpy of formation, NH3, NF3, HF. So enthalpy of formation they will give. Okay, enthalpy of formation for products and enthalpy of formation for reactants, everything they will give in the question itself. Okay, so what we have to do, we have to just substitute it, that's it, and we have to do the calculation. But very important thing guys, very important thing, focus here. Enthalpy of formation for the reactant and enthalpy of formation for the product, they will give in the question. But suppose any one product or any reactant whose enthalpy of formation is not given in the question, we will assume it as a 0. Okay, once again focus, chalo bhai, jaldi. Enthalpy of formation for the products and enthalpy of formation for the reactants, it is given, it will be given in the question itself. If suppose anyone whose enthalpy of formation of product or whose enthalpy of formation of reactant is not given in the question, whose value is not given in the question, that we will take it as a 0. Why we will take it as a 0? What does this mean? That means that whose enthalpy of formation, either product or enthalpy of formation of reactant, the value, if it is not given, we will assume it as a 0. The reason behind is what we will assume this, that enthalpy of formation of any standard element means that element whose enthalpy of formation is not given, okay, that element is in standard state, so that's why its value is 0. So that's why its value is not given, and that's the reason we will assume its value as a 0. Understand? Yes sir. Okay, so how we will write? We will write like this: enthalpy C, right? So C means, see this like this, we will write like this: enthalpy of formation of C, enthalpy of formation of C plus enthalpy of formation of D, okay, this for the product, minus this for the product, minus we have to write for reactant. Reactant means enthalpy of formation of A plus enthalpy of formation of B. Okay, right? This they said the same thing. They said the summation of enthalpy of formation of product minus summation of enthalpy of formation of reactant. The same thing, right? Summation of enthalpy of what? Formation for the product minus this summation of enthalpy of formation of reactants. But very important thing guys, this coefficient, it will multiply here. C means its coefficient will multiply here, D means its coefficient will multiply here, A means its coefficient will multiply here, B means its coefficient will multiply here. Don't do the mistake. Some student, they will not multiply the coefficient in hurry burry, or some student in hurry burry they will they will do the coefficient in the power only. So don't do that thing. Okay, what we have to do? Same method, just we have to multiply its coefficient and value. Suppose this formation, enthalpy of formation of C is given, we will write its value, multiply by its coefficient. Then if suppose D, enthalpy of formation of D is not given, means we will take it as a 0. Why? Jaldi bolo bhai. Why will take it 0? Yes, because it is present in the standard state of an element. So if standard state of an element, then its formation, enthalpy of formation will be 0. Okay, like that we will substitute. If its value is given, we will substitute. If its value is not given, we will take it as 0 and then multiply with its coefficient. Then formation of this product minus formation of this reactant, we will get the enthalpy of reaction. Okay, now we have to solve the problem. So question number 1, let's see. Okay, delta. So this you understand. If you want guys, you can write, otherwise if you understand, it's fine, well and good. So after this reaction, now we'll solve the problem. Okay, so question number 1 is delta HF naught, means we have to find what? We have to find, yes, standard enthalpy of formation. This indicates standard, this indicates enthalpy, and F means formation. Standard enthalpy of formation will not be 0, will not be 0. Okay, will not be 0 for which of the following? For which of the following? So what is this? This is standard enthalpy of formation will not be 0. Will not be 0 for which of the following? Options are this: sodium in solid, it is given. Br2 is given in the liquid. Carbon is given in the diamond. And then hydrogen is given in the gas. So let's see whose will not be 0. Whose will not be 0? Jaldi bolo bhaiya. Whose standard enthalpy of formation is not 0, which is not present in the standard state of an element. Let's see. Sodium. Right, enthalpy of formation of any standard of state of element is 0. So who's not 0? Which is not present in standard state of element. Sodium. See here, sodium तो नहीं लिखा ना, carbon oxygen. Okay, fine. Here, if suppose it is not written, but sodium will be in solid form. Sodium we know it in soft and solid form, so it will be cut with a knife. So sodium का standard form is solid. You can write. Bromine. Bromine means देखो भैया. Bromine means liquid. Fine, it is present in liquid. So it is standard form. It is in standard form. This is standard form. The standard form means it's 0. Its value is 0. Now hydrogen. Hydrogen obviously guys. H2 means what? H2 is a gas. Hydrogen is what? Here it's not given, but hydrogen we know. Hydrogen is a gas. Standard form for hydrogen is gas 0. Now see here, carbon diamond. Carbon diamond. Its carbon should be in graphite. Then only it is in standard state. So here the get given carbon in the diamond. This is not in the standard state. So its enthalpy of formation is not equals to 0. Answer is this, C. Now next question. Okay, after this, right, after this standard enthalpy of reaction. Okay, after this we'll solve these questions. The first number is done. Okay, so what you have to do guys, you have to solve this, means write the question, and then this slide you have to write. Okay, write the question, then write the answer. Then next question guys, which of the following represent, okay, so which of the following equation, the question is write down which of the following equation represent delta HF naught. So which of the following will represent the delta HF naught? So if representing delta HF naught means representing the standard enthalpy of formation. So who will follow the standard enthalpy of formation? Who will be in the standard state of element? Who will be in the standard state of element means 0. Okay, let's see the first option. First option is carbon is present in diamond. Okay, which reacts with oxygen which is present in gas form. It will give CO2 which is present in gas form. B is half H2 which is present in gas form plus half Br2 which is present in the gas form. It will give HBr which is present in the gas form. Then next is carbon which is present in graphite form, reacts with oxygen which is present in liquid form. It will give carbon dioxide which is present in gas form. Then D is half H2 which is present in gas form plus half Br2 which is present in liquid form, gives HBr which is present in gas form. So first of all what we will see guys, first of all we have to know that 1 mole. So it is 1 mole, 1 mole, 1 mole, 1 mole. All are valid till here 1 mole. Okay, because standard means what? 1 mole. Now we have to see that whose delta means which of the following like equation gives this delta HF naught, means what it just means. This means that which will give the standard enthalpy of formation. Who will give the standard enthalpy of formation? Who is available in its standard state of element? Who is available in its standard state of element? So carbon standard state is graphite, not the diamond. So this is not possible. Okay, then but oxygen, oxygen is present. This carbon dioxide is also, oxygen is present in standard state gas. So this is not present, this is present. So it is obviously it is not equal to 0, right? This is here. All are 1 mole, 1 mole, 1 mole, 1 mole. Okay. So what we want? We want the formation means what guys? See here. Read here. Formation means what we want? We want the formation of 1 mole of compound. Formation of 1 mole of compound. So you can see here. This is the formation of 1 mole of compound. This is the formation of 1 mole of a compound. This is the formation of 1 mole of a compound. This is the formation of 1 mole of a compound. Okay. Okay, this is the formation of 1 mole of compound. This is the formation of 1 mole of compound. So this all is satisfying the product side. The product side is satisfying. We have to see the reactant side. Reactant side should be in the standard state. See here what they said. Form the element in their standard state. So we'll form the element in their standard state. So carbon is not in the standard state. It is in, carbon should be graphite. This is in the standard state, so it is not possible. Here H2, yeah, H2 is gas, it is in the standard form, but Br2, no, Br2 should be liquid in the standard form. This is not possible. Carbon is graphite, yes, in the standard form. Oxygen is liquid, no, oxygen should be gas in the standard form. So this is also not. Hydrogen is gas in the standard form, yes. And Br2 is liquid, yes, liquid in the standard form, yes. This D is in which the delta HF naught is forming means delta HF naught is 0. Okay, yes. Now next, write on this. Next means guys, write on this question. Yeah, this one. Next is this question. What will be the enthalpy of following reaction? What will be the enthalpy of reaction? You have to find the enthalpy of reaction. You have to find the enthalpy of reaction. So we know enthalpy of reaction means what, right? Enthalpy of formation of product minus enthalpy of formation of reactant. So on the basis of enthalpy of formation of data given, enthalpy of formation data given, so this is the reaction NH3. What is the coefficient? 1. Okay, 3 coefficient F2 gives NF3, 1 coefficient plus HF, 3HF. Okay, fine, chalo. Guys, what we have to find, write on the question, and after the question we have this answer. So we have to find the delta, this enthalpy of reaction, So first of all we will take for the product. So what is the product? HF. So, we will see the enthalpy of formation of HF is given or not. Enthalpy of formation of HF, see they are given the values of enthalpy of formation. NH3 is given, NF3 is given, HF, yes, HF is given. What is the HF? Minus 269 into its coefficient. The coefficient is 3. Okay, then in the product next is NF3. NF3 value is given, NH3 is given, NF3 is also given. So plus minus 113. NF3 is how much? Coefficient is 1. So multiply with 1 means we'll get the same one. So this is for the product minus enthalpy of formation of reactant, right? It is summation of enthalpy of formation of product. So summation we are doing, right? Summation. This means summation. Now next we'll do for the reactant. Reactant means this NH3 value is given, yes, it's given, minus 46.2. and what is the coefficient? Coefficient is 1. To multiply with 1 it will remain same. Then F2 no, F2 value is not given. Enthalpy of formation of F2 is not given. So if it is not given, we will consider it as a 0, right? Why we will consider it as 0? We will consider it as a 0. We will think that it is in the standard state of element. So enthalpy of formation of the standard state of an element is 0. So that's why its value is not given. We will consider it as 0. So now we'll do this. So you will do minus 269 into 3. So it will be 327, 7, 6, 3, 18, 2 carry. So see, when you will do this, you will get minus 807 and this plus minus 113, and then see this minus plus 46.2. So now we will do this delta HR. So minus plus, but it will be minus. Okay, so 819 minus 920, then plus 46.2, minus plus minus. So you will do, guys, see, minus plus minus, we will do the minus. Let's do the minus. 920 so minus करेंगे 46.2. 920 minus 46.2, we will get 873.8. See, minus plus minus, so 920 minus 46 is 873.8, and then which is bigger? 920 is bigger, so 920 is having minus sign, so it is minus 873.8. This is the correct answer. Okay, that's it. Simple thing guys we have to do. Now next is this. After that, after this sum, we will continue this. Enthalpy of formation. Now, sorry, enthalpy of combustion. What do you mean by combustion? Joldi bolo bhaiya. Combustion means, yes, burning in presence of oxygen. So combustion means what? Enthalpy. So again guys, this is standard. ये स्टैंडर्ड है भाई, स्टैंडर्ड इंथैल्पी ऑफ कंबस्शन. स्टैंडर्ड मीन्स देन ओनली वी विल टेक द स्टैंडर्ड वैल्यू ऑफ 1 मोल एट स्टैंडर्ड conditions. So in standard enthalpy of combustion means, enthalpy means what will happen? Heat evolved. So heat evolved at constant pressure. When standard means what? When 1 mole of substance completely reacts with oxygen. Because combustion means what? Burning in presence of oxygen. So heat evolved at constant pressure when 1 mole, standard means what? 1 mole of substance completely reacts with oxygen. Enthalpy of combustion. The unit is kilojoule per mole. Now this is very important. Combustion, okay, combustion reaction are exothermic reaction, and so enthalpy of combustion is always negative. Exothermic means it will release, right? Because combustion means what? Burning in presence of oxygen. So whenever we do the burning in presence of oxygen, what is happening? Heat is released. Heat is released. So released means exothermic. Okay, exothermic means, so that's why it's always negative. Now next we will do this sum. Write on this question, guys, and then we'll solve the sum. They said enthalpy of combustion of glucose, this glucose is this much, 280.8, 280 minus 280 point, no, wait. Sorry, it is minus 2808, minus 2808. So enthalpy of combustion, okay, here we'll do enthalpy of combustion of glucose. How much glucose is given? 1. So we'll take the 1 mole of glucose, right? So combustion means what? Combustion means, देखो भैया, combustion means 1 mole. Combustion means 1 mole of substance. Combustion means जल्दी बोलो रे, जल्दी रे. Combustion means 1 mole of substance रे भैया. So here combustion of glucose. Glucose means how much is given? We'll take the 1 mole of glucose रे bappa. So answer is C. Answer is 1 mole of glucose. 1 mole of glucose. How much it will give? Enthalpy of combustion of glucose means 1 mole, right? 1 mole of glucose is minus this much. 1 mole of glucose, it's minus 2808. Okay, 1 mole of glucose is minus 2808 kilojoule per mole. Calculate the heat evolved when 9 gram of glucose is burnt in air. So we have to find for 9 gram of glucose burnt in air. Very simple, guys. 1 mole of glucose. 1 mole of glucose is how much? 1 mole of glucose is this much kilojoule per mole. So 1 mole means this 1 C6H12O6, right? 1 mole of glucose means 1 mole of this glucose is minus 2808 kilojoule per mole. So 1 mole of glucose is how many gram? 1 mole of glucose, we'll find the molecular mass, right? We'll find the formula mass here. So carbon is 12 into 6 plus hydrogen atomic mass is 1 into 12 hydrogen plus oxygen atomic mass is 16 into 6. Okay, so this much we'll get in gram, which is equals to this much kilojoule per mole. So when you will add this 12 6 the 72 plus 12 1 the 12 plus 96 16 see the 96 gram, right? A gram of what? Glucose. Gram of glucose will have this much. Okay, so this if you will add, it will be 180. So 180 gram of glucose, 180 gram of glucose will give this much. Okay, see, obviously they had given 1 mole of glucose, it is this much. 1 mole of glucose means this, right? 1 mole of glucose, 1 mole of C6H12O6 is this much. So we'll find the molecule, means formula mass, molecular mass, we know how to find. Carbon, this gram, this much is equal to this much. So when we will add this much gram of glucose, will hold this much. So total add means 180 gram of glucose is equals to minus 2808. So we have to find for 9 gram of glucose. See, we have to find for gram. So that's why we have changed here in the terms of gram. We have to find for gram. So that's why we have changed in terms of ग्राम. सो 180 ग्राम का भैया इतना है, तो 1 ग्राम ऑफ ग्लूकोज कितना होगा, जल्दी बोलो रे। 1 ग्राम of glucose is minus 2808 kilojoule per mole. So we have to find for 9 gram. The next page we will write 9 gram of glucose. 9 gram of glucose means, see, 1 gram of glucose means this much divided by 180. I know 1 gram of glucose is equals to this much divided by 180. So 9 gram of glucose means minus 2808 divided by 180 into 9. Correct? So it will be 9 1 the 9, 9 to the 8, 20. So when you will divide, you will get the answer 9 gram of glucose. When you will divide, you will get the answer minus something, you will get minus 140.4 kilojoule. This is the correct answer, right? Okay, so this is for the today's class. I hope you understand the thing. In the next class we are going to continue with a very important topic, that is Hiss's law. Okay, so keep on watching and keep on learning, and by 15th or 20th of January, by before, like you can say by 20th of January, I am going to upload whole the content for the class 11th chemistry based upon completely NCERT. Okay guys, so we will solve the NCERT text, like NCERT exercise questions also. Okay, so because which is very important in the examination, mostly they will ask the questions from NCERT in-text questions, NCERT examples, and then NCERT exercise. So that is very important. Okay guys, thank you, bye bye, we'll meet in the next video.